Welcome to the Research Cone Demonstration Trial of the University of Southern Mindanao in Cabacan, North Cotabato, Philippines. We are very happy and proud to share our demonstration sites of the project, Land Management in Diverse Rubber-Based Farming System. With me today are our project team, the dedicated research assistants, the field assistants, our thesis students, 13 major in soil science, and 9 are major in entomology. The program objective is to boost household income for indigenous and smallholder farmers through developing a rubber-based cropping system that increases smallholder farmers' income through crop diversification, identifying key soil constraints, improving soil nutrient management practices, and enhancing pest and disease management in the uplands of southern Philippines. There are 6 project components. Component Project 1 is on cost-effective rubber-based cropping systems in Agusan del Sur and North Cotabato. Component Project 2 is land suitability analysis for rubber crops in Agusan del Sur. Component Project 3 is developing rapid, robust nutrient diagnostic tools and effective chemical formulation to improve productivity. Component Project 4, development of cost-effective pest and disease management for rubber and intercrops. Component Project 5 is economic studies on rubber-based cropping system in southern Philippines. Component Project 6 is capability building of rubber stakeholders and role of women and children in natural rubber industry. This is funded by Aciar, the Australian Centre for International Agricultural Research, and PICARD, or the Philippine Council for Agriculture, Aquatic and Natural Resources Research and Development. The partners in the implementation of the program are Griffith University in Australia, the University of Southern Mindanao in Cabacan, North Cotabato, Philippines, the Provincial Government of Agusan del Sur, Philippines, and the Caraga State University, Butuan City, Philippines. I'm happy to present to you the project component 1, the cost-effective rubber-based cropping system in North Cotabato. Actually, there are 2 sites for the conduct of this experiment. One is in North Cotabato, conducted at the University of Southern Mindanao, Cabacan, North Cotabato, Philippines, and in Agusan del Sur, Philippines. There are 2 sites in Agusan del Sur, in ARC Mabuhay, Bayugan City, Philippines, and Trento, Agusan del Sur, Philippines. We successfully implemented the field trials in December 2019. And in the field, we have planted the main crop, and that is rubber, and the intercrops, the perennial intercrops, including the annual intercrops. So there are 4 models here that we are trying to evaluate. So we have now the models in place. We have the first model, rubber plus banana. The second model is rubber plus cacao. The next model is rubber plus coffee. The same planting distance is still 3 by 3 meters. And rubber plus lanzones. The control for this experiment is the rubber monocrop. planted at 4 by 5 meters. Our research cum demonstration site now is going second year, and on the 5th year, we hope to be able to evaluate which farming system model would be most beneficial or appropriate for a particular socioeconomic condition, so farmers will have an option. They could select rubber plus banana, rubber plus cacao, or rubber plus coffee, or rubber plus lanzones, the longkong variety, or rubber monocropping. It's a choice.
The Project 2 team is headed by Dr. Adefler Garcia. Together with her is Mr. Neftali Morgado and Mr. Richie Later as her project staff. This project is entitled Land Suitability Analysis for Rubber Crops in Aguasandal Sur. We will present its status and accomplishments. Before going through the journey of this project, we will revisit the objectives of the study. Its first objective is to characterize the key soil constraints and identify most suitable lands for establishing rubber-based cropping systems for long-term sustainability under a changing climate. Second objective is to establish a database and maps of pH, clay content, key nutrient distribution, topography in one selected subcatchment. And the last objective is to establish the suitability classification and land use planning for the rubber-based intercropping systems in one selected subcatchment. We have done literature review, soil data, landscape, and socioeconomic information of the upland barangays. All of these resources has been uploaded in our project website for ease access. The team was able to process and upload 55 electronic maps in our website. It contains map features on farmers and farm demonstration sites, soil sampling grid, topography, soil physical and chemical characteristics, land use, geologic, watershed, and other map layers available online. The team also prepared 42 printable maps organized using QGIS. There are 14 generated geology map. It's a combination of elevation and geology. Another 14 generated geology map, a combination of soil series and geology. The last set is another 14 generated limitations and constraints map. We're able to send 616 soil samples to Griffith University, Brisbane, Australia. As of now, still awaiting for the result. Our system is now ready to facilitate the encoding of the laboratory result, either building it up directly into the system by clicking the edit image icon, or by importing it through Excel file format. Our online mapping system or the GIS can be accessed by opening our browser because it is a web-based system, and type the URL https://pegas.ph, then hit enter key. You will view the employees portal of the Provincial Government of Aguasandal Sur. Among different image links and information in the portal, you have to hover over the monitoring and evaluation group of systems. Upon hovering into it, you will see Aciar link. Just click that. After clicking the Aciar link, you will be rerouted to this web app. You may provide username for first-time user, but for the repeater, you can just click the stored username. Provide a password and click the login button. Voila! This is now the landing page of the Aciar project website. This landing page features the calendar of activities and the financial status of the project. On the left pane, listed are the menus such as dashboard, calendar of activities, trials, literatures, reports, media releases, communications, Gantt chart, project member profile, and organization chart. It has also menu for map resources, where our online maps are stored, the Aciar Rubber Forum, finance, maintenance, and the survey result. As an example, clicking the literatures menu, it will display all the uploaded materials classified as literatures. You can download it, remove, or edit. Emphasizing on the map resources, clicking that menu will reroute us to the GIS module of the system. The Geographic Information System of Aciar project. User may change the base map by clicking the drop-down list, and choose the most appropriate map for a study. They can choose terrain, satellite, OpenStreetMap, or hybrid. Below the base map option, a group of map layers grouped into three, the Aciar project, other map layers which contains available and existing map of the local government unit, and the last group is the processed map layers. This group contains results from the multiple clipping geoprocessing operation. On the other hand, on the left pane of the page, a map legend and display control is located. This is where the GIS basic operation can be found, such as the name of the layer added, a close button that will cause immediate removal of the layer from displaying, a zoom in and out control buttons, and other operations. The most important of all is the geoprocessing operation. Clicking this button will display the criteria and parameters for calculating soil suitability analysis. When you expand a layer, you are provided with a lot of operation, a button to display the attributes of the map, a summary button, opacity to control and adjust transparency of the map layer, displaying and hiding the label, and changing the font size. On the bottom part is the legend with corresponding polygon color, in which case, user can customize the color and the pattern. Looking at the map layers, under the point group, it shows the average annual rainfall, temperature, farmers, soil sampling grid, farm demonstration site and the OSID farmers. So far, in this project, there is no map inline features, thus, it's empty. For the polygon, it has topography, soil physical and chemical characteristics, land use, geologic, the semi-processed layers, and the watershed. Expanding the topography group of layers, it contains elevation and slope. Under soil physical characteristics are soil depth, texture, drainage, and flooding. For soil chemical characteristics group, a layer for pH, CEC, and base saturation can be found. Loading the previously mentioned layers, this view is a sample of the farm demonstration site. On the right side pane is a checked layer name, and on the left side pane is the loaded layer name containing other information and operation as you expand it. Clicking on the point, it will display the attribute and data of that particular point such as the object ID, barangay name, municipality name, the cooperator, and other attributes embedded into the layer. This layer is the soil sampling grid. A soil sampling grid in zoom-in view. Clicking directly on the point will prompt data about the grid. This shows that the selected point is in the municipality of Prosperidad. A zoom-in view of the map. To display the attributes, clicking the Attributes button will display a grid containing all the points or features of the map. There are 4 buttons at the top of the grid, namely, Copy, CSV, Excel, and PDF. Clicking these buttons will export the data to desired format. This map shows the soil physical characteristic, particularly the texture. To determine the summary, clicking this image icon will display the summary and the total hectarage. From that pop-up form, you can change the summary attribute by clicking the drop-down list, and then select the desired parameter, and the system will calculate the summary for you. So, as per previous slides, it showed the summary per texture, but as of this time, it displays the summary per soil series. Still the total hectarage is the same. This slide demonstrates different map layers loaded, namely, OSID Farmers, Soil Sampling Grid, Farm Demonstration Site, Elevation, Slope, Land Use, Watershed, Flooding, and Soil Series. This is the proposed suitability criteria for rubber to determine the highly suitable, moderately suitable, marginally suitable, and not suitable area in Aguascalientes Sur. There will be 11 layers involved, namely, annual rainfall, temperature, slope, elevation, depth, texture, drainage, pH, CEC, organic matter, and the last is base saturation. In determining the suitable area, the team proposes 2 options. The first is a series of geoprocessing clip tool, which is based on vector. It is dynamic simply because anybody could manipulate and play around with the criteria and see the result online. The second option is using a multiple geoprocessing tool. It is basically a raster based, converting vector to raster, then raster to vector, back and forth, done using QGIS, manually, takes some time to process. To elaborate the option 1 operation, the first layer will be clipped with the second layer. The resulting clipped layer will then be clipped to the third layer. The resulting clipped layer will then be clipped to the fourth layer, so on and so forth. At the end of the processing is the rubber suitability map. Option 2 processing, reclassifying the soil characteristics, climate characteristics, and the topographic data. The reclassification is taking into consideration the parameters of the rubber and intercropping requirements. A weight and rank was established to be considered in the manipulation of layers to come up with rubber suitability. To demonstrate the option 1 soil suitability operation, clicking the button Geoprocessing will display the criteria configuration page. In this page, you can add and remove layers dynamically depending on what criteria you want to play around and see the result right away. You can select attribute and specify the values as parameters. After setting all the conditions, configuration, and criteria, clicking the process button will do series of clipping geoprocessing operation, on the fly. In this view, the first layer is the watershed, and the layer displayed with pattern filling is the resulting layer of the series of clip operation. That shows the highly suitable area for rubber. Upon clicking the summary button, it displays the total area disaggregated by soil series, which has a total of 44,086 hectares, which is 33% of the Hibong watershed area. As of now, the team is still enhancing and perfecting the option 1 geoprocessing where bugs are still encountered. Once these issues will be fixed, it will be a tool for local planners to identify possible areas for a certain commodity with ease and convenience without needing so much technical expertise in geoprocessing. We are also in the process of developing modules to print maps online. That's all for the project 2. Thank you very much for time.
Presenting to you the Project 3 team with our head, Dr. Aciar Garcia, our research scientist, John Vigoloran, the project staffs, yours truly, Dr. Melquisel Sales, and Mr. Oscar Horado, and our research assistant, RG Casis. Also involved are our students of USM, Soil Science Department.
Hi, we are the Project 3 team.
Working with their studies, Jonah May, John Kenneth, Freddy, Spencer, Teresita, Wilson, Al, Mar, Sahara, Kate, Jean, Mario, and Laura. To achieve this, we conducted studies in rubber plantations of different ages. We applied different fertilizer rates and organic fertilizers in areas with and without mucuna cover crops. Growth and yield response of rubber were observed. Soil, plant, latex, and leaf litters were collected. These were processed in the Usmardzi Central Laboratory and were sent to the laboratory in Griffith University, Australia.
Hi, I'm proud to present to you the Pest and Disease team with Dr. Joanne Sadural, a plant pathologist assisted by Marife, yours truly, an entomologist assisted by Miss Lira and Miss Miriam. And we are supported by able support staff, Miss Almira and Mr. Jason. And I'm also proud to present to you our undergraduate students who are working here at the Aciar Picard area for their undergraduate thesis, with Abby working on stoichiometry of insects, Danuel and Jejuma working on the annual crops, Rachel working on the perennials, and Marian working on the natural enemies. In this project, we will assess the pest and disease profile of its cropping systems model, and we are going to evaluate which of these pests and diseases are the most major ones. This is the damage of the pakiringkid beetles on the leaf of coffee. I'd like to show you a new pest recorded in rubber. This is the scale insect. It looks like the scale insect of Lanzones, but still for further identification. This is the damage of the eggplant shoot and fruit borer. It damages the shoots as well as the fruits of eggplant. With Abby, my undergraduate student, we are trying to look into the nutrient limitation of its cropping system model using the most abundant insect orders that we find in the area. And for this, we have the order Orthoptera, which are the grasshoppers.
This is bird's eye spot disease, and this is caused by a fungus known as Helminthosporium hevei. Another disease of rubber is known as stem rot, and currently we are on the process of determining the identity of the causal organism through its cultural, morphological, and molecular characteristics. This corn plant is infected with the stalk rot disease. The disease is caused by a bacterium known as Erwinia chrysanthemi pathovar sayi.